A closed pipe is another way to produce sound. And a closed pipe isn't a fully closed pipe. It really is a pipe where you have one end open and the other end closed. Key thing with a closed pipe is in order to produce sound, you need to create a standing wave. But because we have one end open and the other end closed, what has to happen in order to produce a standing wave is we have to have on the closed end, so let's just say this end on the right here is a closed end, we have to have a node. Because basically the sound is going to hit this closed end and reflect back. So we're going to have a node on this end. But we also have to have an antinode on the open end in order to hear the sound that's going through. So for our fundamental frequency that we have, the smallest wave that we can produce is just a wave where we have an antinode to a node. So essentially it's a standing wave that looks like this. Now if you look at this standing wave, it's actually not a loop. It's only half of a loop. Since it's half of a loop, that means it's equal to 1/4 of a wavelength. If we knew that the length of the pipe was L, that means that L is equal to 1/4 of a wavelength. Which means if I were to multiply both sides by 4, that means that one wavelength is equal to 4 times L. Now, to put this in perspective, if I use my velocity equation, so velocity equals frequency times wavelength, so the velocity is equal to the frequency times 4L, which means the frequency, if I divide both sides by 4L, the frequency is the velocity divided by 4L. Keep in mind that the velocity is fixed. So that velocity is the speed of sound that we have. Now, if we were to look at the next resonant frequency, so this is the fundamental, this is going to be my next harmonic. Okay, I'm not going to say exactly what it is because I want you to kind of see the way it's going to work here. But this is going to be my first overtone. Just label it as the first overtone for now. Now, in the first overtone, I still have to create the same type of wave, where I have a node on my closed end and an antinode on my open end. And the only way I can actually do that is to create a wave where you have not a full loop. It's not possible to create one full loop in here, but I actually have to create 1.5 loops. So 1.5 loops, this is equal to not 1/4 of a wavelength, but this is actually going to be 3/4 of a wavelength. So if my tube is still of length L, that means that L is equal to 3/4 of a wavelength at this next resonant frequency, at this first overtone that we have, which means the wavelength is 4/3 L. Now to kind of put this in perspective, if I use my wave velocity equation again, so velocity equals frequency times wavelength, now if I just plug this in, and if I do a little bit of algebra here, I get frequency is equal to velocity divided by 4/3 L. But to simplify this, I don't want to have a fraction down there in the denominator. It ends up being frequency is 3 times V over 4L. Or another way I'm going to write this is 3 times V over 4L. The reason why that's important is because I want you to see that if this fundamental frequency is V over 4L, this is your fundamental, which means this frequency of this first overtone is not going to be 2 times the fundamental, it's actually 3 times the fundamental. So this is not your second harmonic, this is your third harmonic. So your third harmonic is your first overtone in your closed pipe. If we continue on then, for the next overtone, so this is the second overtone, If I create the next wave in here, this is what it's going to look like. So here's my standing wave. So now I have 2.5 loops. So that's 5/4 of a wavelength, which means that if this is L, again, the length of our tube, L is equal to 5/4 lambda, which means lambda is equal to 4/5 times L. Now, just to kind of simplify this fairly quickly, if I use my equation again for wave velocity, what you end up getting is that the frequency here is 5v over 4L, which means that's 5 times v over 4L. So it's 5 times our fundamental. So this is not our 4th harmonic, this is our 5th harmonic. So what's really interesting and important, and I want you to see this, is that when we're talking about the multiples of our fundamental frequency, it's not possible with a closed pipe to have even multiples of your fundamental frequency. So if this were 100 hertz, the next possible resonant frequency you'd have in your closed pipe would be 300 hertz, and then 500 hertz. We cannot physically create 200 hertz or 400 hertz because of the way that it's set up. In order to have an antinode and a node at one end, we can only go in odd harmonics with our closed pipe. So it's really important that you understand the breakdown here and how to figure that out. Worst comes to worst, you can always do what I did. You can always draw it out, use your loops, use your wave velocity equation to figure out exactly what you have.